Hi, my name is Bikash. I'm a PhD student at Auburn University and also a graduate research assistant at Vehicle Systems Dynamics and Design Lab. You might be aware of the discussion and development in a new mode of air transportation for short distances, commonly known as air taxis. So our lab does a lot of research on air taxis, and different small vehicles you see in my background are the small prototypes of those air taxis, and I'll walk you through each of these. So, so this looks very much like a conventional aircraft designed for takeoff and landing, but the difference is that it has a lot of many small propellers. This in technical term is called distributed electric propulsion. This helps maintaining a airflow over the wing, and companies are trying to use these for delivering cargoes, using runways that are shorter than the conventional runways. And on my right, you see a unique concept. It has got the tilting motor and propellers. So four motor propellers in the front, they are like in vertical position when they take off, and once there is a suitable height, these all tilt forward to cruise. And there are other aircraft concepts in the background, and all of these are some miniature aircrafts that, when scaled up, could be used for cargo delivery or delivery to passengers over short distances. So my role in all these aircrafts is some part of sizing. So when we have mission and we want to find out how big the aircraft parts are going to be, how big the motors are going to be, or the like how big the aircraft surfaces are. So I have some role in that. I perform aerodynamic modeling, and then we do simulation of the aircrafts. I'm also involved in making simulation model. So this is one of the big simulators under constructions. We have two downstairs, and we also perform simulation using a ground control station. I'll show you that later. And after this, we do the simulation. We implement the control system that we use in the simulation model onto the hardware, and we go into the flight testing field and actually fly these aircrafts and collect data and bring back data to improve the simulation model. So now I'll walk you through the ground control station, also the simulation, also the simulator. So you can come behind me. So this is a ground control station. This is the actual setup that the pilot uses to fly the aircraft. So and now this is used in the simulation mode. So what this means is that, like, before flight, we use this to simulate the whole mission of the aircraft, and then we take the same setup to the field and use the same setup to fly the aircraft. And we use a system called simplified vehicle operations. And what this means is that, like, the pilot has to have minimal effort to fly the aircraft. So all of these control inceptors, they command directly what the pilot wants to do, and there are touch displays. The pilot can, like, just click the button and the vehicle will perform the mission automatically. And there are a lot of displays in here that the pilot can use to monitor the state of the aircraft. My dream to pursue aerospace engineering began when I was in 10th grade. We were a bunch of friends talking about our dreams, and I said I wanted to go to space and then look down on the earth. And then I wanted to study aerospace engineering, but in Nepal there was no aerospace, so I chose mechanical, did some projects in aeronautics, and then after my graduation I worked with a drone company. And my love for space converted into love for flying small aircrafts. And then Auburn University was doing so many small scale aircraft projects, and then hey, I wanted to go there and, like, do the same stuff, and I came to Auburn, and I'm doing all this flying. This is cool.